Okay, you ready? So we're going to answer the question of why is it necessary to check every apparent solution of a radical equation into the original equation. So we've shifted gears, okay? We're kind of skipping around and getting all these algebra skills that kind of match this first unit before we enter the pre-calculus book. So we're picking up those ones out of the Algebra 2 that aren't in the pre-calc book, okay? We have about 3 or 4 days of this, and then we finally move into our pre-calculus books, okay? So this lesson is about radicals, okay? So we could call it a really radical lesson today. You might not feel that way at the end, though, all right? So we're going to start with this guy right here. This is we're going to review our exponents a little bit here, okay? And these are mostly reviewing the fractional exponents. I know you understand exponent rules, hopefully. Okay, so I'm not going to go through those. I'll go through them as we're doing it. So, when we have a fractional exponent, we are able to convert it into a radical, okay? So, when you talk about the trees outside, the ones with the leaves on them, where are the roots of them? At the bottom, okay? So at the bottom of the fraction is what goes in the root. That's the best way I can think of to explain it so that you'll remember it, okay? We can go backwards with this too. If there's a number in the root, you put it at the bottom of the fraction to make the fractional exponent. You do need to be able to make that conversion in this, okay, and make it quickly, all right? So in example A here, if I went and I'm going to convert it to a radical, what's going to go in the root symbol? 5 in the root part there, right inside that little angle, okay? And then we would write x to the 4th. All right, everybody try B on your own. 5 seconds. All right, what should go in the root symbol there? 4x to the 3rd. Perfect. Okay, now we're going to go backwards. So on this one, we got to convert to the fraction. So we're going to go x to the 2 divided by what? 3 is in the bottom. All right, everybody write down D on your own. 5 seconds. All right, we get x to the what power? 5/6. And you notice how I write my fractions, how I write them like this, and I try not to write them like that. The slashy fraction is bad because it's hard to tell what your denominator is, and sometimes it makes it harder to cancel things. So try to avoid the slashy fraction, all right, even though I accidentally write it sometimes. All right, go ahead and fill in those blanks. Okay, so we are going to so when you forget what you're doing on your homework, the first thing you do is you go look at your notes, right? So this box should help you hopefully remember the steps that we did, okay? So the first thing we're going to do is we're going to isolate the radical on one side of the equation if necessary. Sometimes the radical appears on both sides of the equation, okay? So we sometimes have to get it all to one side, okay? Then we're going to raise each side of the equation to the same power to eliminate the radical and obtain a linear, quadratic, or other polynomial. So the factoring and the quadratics that we did before are not going away, okay? Step 3 is that we're going to solve the polynomial equation using techniques you've learned in previous chapters. Our other chapters out of this book that we were working with were 4 and 5, and this one was in 6, so that's what they're talking about there, okay? So basically solve it using your factoring techniques, okay, or quadratic formula techniques. And then we're going to check our solution, okay? All right, so we need to solve the equation, and then we need to check the solution. In theory, the first few, the check works out really nicely, but you're going to see at some point with the radicals, the check gets ugly, and some of the answers we get don't work, okay? So we eventually end up with an extraneous solution. All right, so we want to undo this. To undo it, we raise it to the exponent. So what exponent would I raise this to, do you think? The cube, the third, right? And that's what we call it, is we call it raising it to the third power, okay? So instead of squaring it, you say squaring. You could say cubing. If this was the fourth, we say raise it to the fourth power. All right, those things end up canceling, so I get 2x plus 7 equals, what's 3 cubed? Good. If you don't remember it, you can use your calculator, you can use the walls, right? All right, what am I going to do to move the 7? Subtract it. So what's 27 minus 7? 20. Good. And what am I going to do to move the 2? Divide it, so we end up with x equals 10. All right. I'm drawing a line because I'm going to do my check under my line. I don't need to write down a ton for my check. It's more for me to make sure I don't get it wrong on a test. Okay? I'm never going to actually grade your check. Okay? So, I'm going to put in a 10 into this side over here. So what's 2 times 10? 20. Plus 7 is? What's the cube root of 27? Do you see how much of a check I wrote down? Not much, right? I could probably do that in my head. I write it down because sometimes we have x's on both sides. I'm forgetful. I'll forget what I got on the left and not know when I calculate the right. So this is a good answer. I could go ahead and box it. That's my final answer. Okay? All right. Let's try the next one together here. All right, what do we need to do? I got to get everything off of here. So if there's an add, subtract, or a multiply or divide, I got to move it to the other side first. So what am I going to do with that 9? Add it. Good. So we've got the cubed root of x equals, when we add 9 to the negative 1, what do we get? 8. Good. Remember, we're changing the signs. And I'm not writing down the plus 9s. I'm assuming we're doing that in our heads. If you need to write down the pluses, that's fine. Okay? All right, to undo the cubed root, what do we do to both sides? Raise it to the power of 3 or cube it. Either one. Let me get rid of the plus 9s because those are just now confusing. Okay. So be careful because we are cubing it, which means 8 times 8 times 8. So what do we get for 8 cubed? 512. Good. I'm going to check it before I say that that's my final answer. So if I put 512 in there, what's the cubed root of 512? 8. What's 8 minus 9? Did it work? Yep. So 512 is a good answer. Okay. All right. Let's try. Actually, I want you to try example 3 on your own. Okay. Example 3 is similar to 1, only you got a square root instead of a cube root. So everybody's doing 3 right now. Okay, let's go ahead and check it. So, what do we need to do to both sides? Square it, right? So we've got x plus 25 equals what? Good. And what are we going to do with that 25? Subtract it. Good. What do we get when we subtract it? Okay, sometimes negatives are problems under radical signs. We don't really want to come out with i's. We want real number solutions today if we can. Okay? So what's negative 9 plus 25? Square root of 16 is 4. Did it work? Yep. So that was a good answer. All right, let's try the next one. A little bit different on this one. We are multiplying. I got to get that multiply off of there first. So how do I move the 2 to the other side? We're going to divide it. Good. So we've got the cubed root of x minus 3 equals, what's 4 divided by 2? All right, how do we undo the cubed root? Cube both sides, so we got x minus 3 equals, what's 2 cubed? Good. What are we going to do with this negative 3? Add it. Okay, so when we add negative 3 to the 8, what do we end up with? 11. All right, let's check the 11 back into the original. I know we got to try to get it to equal 4. What is 11 minus 3? 8. Good. What's the cubed root of 8? 2. 2 times 2 is? Did it work? Yep, that was a good answer. All right, flip to the next page. They look uglier, right? Okay. Actually, I think these are better than the square root ones. Okay, I like these ones better. So we have a fractional exponent. We're not going to freak out because it's a fraction. Okay? And unfortunately, the book typed it as the slashy fraction that Mrs. Ballard doesn't like. Okay? So we're going to change that as we're writing it. So first thing I want to do with these is going to act like a radical term. We're going to follow our algebra rules. We're going to get everything off of the x. Okay? So how do I move the 4? Divide it. Good. That's nothing new. We've been doing that for years. So x to the 2/3 equals, what's 36 divided by 4? 9. Good. All right. To undo this, I'm going to raise it to the reciprocal. Okay? Because remember, power to a power, we multiply, so wouldn't these all cancel? Yep. All right, now let's talk about this guy over here. I got a square number there, don't I? So how would I write this as something squared? Why did I do that? What cancels out? The 2 times this 2, right? It's hard to see because this is a numerator and that's a denominator, and I don't have them lined up. But those 2's cancel. So you're looking for that pattern. What if it was a cubed? What if it was a 3 in the denominator? What would we be looking for here? Cubed. What if it was a 4 in the denominator? What would we want? A 4. Okay? So that's how you kind of tell. That's where you start and you try to figure out how to rewrite that number with that exponent. Okay? So now we've got 3 cubed. What's 3 cubed? 27. Remember, it's 3 times 3 times 3. Okay? All right, let's check. Oh, I should probably check it, right? I can check these too. Okay, so let's check it. I'm going to do a little bit more work for my check. Another name for 27 would be 3 cubed, wouldn't it? Yeah. All right, we're checking to see if that equals 36. What happens with the 3's? What's 3 squared? 9 times 4 is? Did it work? Did I have to write down every single little step for my check? No, it's more for you to make sure you're doing it right on a test. Okay, Mrs. Ballard's not going to check your check. Okay, yes?
Can we also do divide by 4 and then put it under a radical and solve it as we work?
Yeah, you could do that too. If you wanted to do, so in this step here, if you wanted to convert it to the cubed root of x squared, you could do that as well. Oops, it was a 9, wasn't it? So, but then you're cubing the 9. Okay, so you got x squared equals, what's 9 cubed? Yeah, that's why I didn't do it that way, because it's harder. And then you got to take the square root of it. So x equals, and over here, technically it's a plus minus probably. Squared is 729, ends up being, what is it? It ends up being 9. What happened? We didn't get it right. 9, oh, it's the square root of 729. You'd have to do it on your calculator. Did it end up being 27? Okay, it's not on my list. Okay, we good? So it does work both ways, okay? Your choice. I like this way better, but it's up to you, okay? All right, let's look at 6 together. So first thing I got to do is get everything off of there if I have to. So what am I going to do to move the 1? Add it, good. So 3/4 equals, when I add the 1, what happens? 8, good. All right, then Mrs. Ballard's trick here was raise it to what power? Reciprocal, so 4/3. So you've got x plus 2 equals, these guys go away. All right, and then we had another little shortcut here. I need to make it cubed because that was a 3 in the denominator. So what's another name for 8? 2 cubed. Okay, what happens with the 3's? Cancel. So you've got x plus 2 equals, what's 2 to the 4th power? It's not a lot. 16. You do probably need to know your powers of 2, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, probably up through about 7 or 8. Okay? You need to know your powers of 3, 3 squared, 3 cubed, 3 to the 4th, up through at least the 4th power. Because this one comes up, in fact, we're going to see it here in a few minutes. Okay? If you don't know those, it'd be a good idea to write those down like your square and your cube numbers somewhere. Okay? Yeah.
I don't know where you got the 2 cubed.
The 2 cubed. Okay, so I took the... I know I wanted a cube so I could cancel, right? So all I'm doing is renaming the 8. And 8 can be written... 8, another name for 8 is 2 cubed. Make sense? Okay, good. All right, any other questions before I go on? Okay, and it's okay to stop me right in the middle. That's good. All right? All right, what are we going to do with that 2 to move it to the other side? Subtract it. What do we get? 14. All right. Should I probably check it? Yeah, I probably should. All right, so let's see. What is 14 plus 2? 16. Another way to write 16 would be, to the 4th power. What's another name for 16 as something to the 4th power? 2 to the 4th, okay. And I'm checking into there. The 4ths go away. What's 2 cubed? 8 minus 1 is 7. Okay, so 14 was a good answer. All right, what I want you to do is I want you to take about 2 minutes. I want you to try 7 and 8. Notice 7 is like 5 and 8 is like 6, right? So you have some examples there if you need to go back and look. So without talking, try it on your own. Give you about another 30-40 seconds to try both 7 and 8. All right, let's go back. Everybody go back to example 7. Let's look at it together, okay? Avalon, what did you do first?
I divided it by the distance.
Good. So we've got x to the 3/4 power equals what, everybody? 8, good. All right. Let's see. Jimmy, what'd you do next?
Multiply them by the square them by the reciprocal.
Raised it to the reciprocal? And what was the reciprocal? Good. So remember, it's raised it to is the terminology we need to use. Okay, so these guys ended up canceling. So x equals, we got to come up with a better name for 8. So Anthony, what'd you get for 8? 2 what? Good. All right. Because we wanted these guys to cancel. That was what we were looking for. So those go away. So x equals 2 to the 4th. And what is 2 to the 4th, everybody? 16. Did you check it? Yes? Did it work? It should have, right? I'm not going to do the checks because I want to keep going and make sure we get through the whole lesson. Okay? All right. On this one right here, we need to raise it to what power, everybody? 3 to the 4th. Good. So we've got x minus 5 equals, what's a better, oh, I told you it was going to come up, didn't I? Another name for 81 is something to the 4th power. 3. You need to know that one. It comes up quite a bit. Okay, so it's one you just need to learn to memorize. Between this year and next year in calculus, we see it. All right, what happens with this, with the 4s? Cancel. So we end up with 3 cubed. I probably wouldn't write that line. I'd probably just do it. What's 3 cubed? 27. What am I going to do to move the 5? Add it. What do we end up with? 32. Again, you should check it. Okay, I'm going to keep going because I want to make sure we get through the harder ones here. So we're not confused on the harder ones. Okay, look at the instructions. See how they changed? They say check for extraneous solutions. All right. That means that there's something that might not work. Now, it's not going to say check for extraneous solutions on your test. But look at the way what happened with the problem. See how there's an X on both sides? That's a good indicator that there could be an extraneous solution somewhere. Okay, so you need to check it. That's why I always do try to check radicals, because you never know. Okay. Remember, when we're doing a radical, it cannot be equal to a negative number. Okay, so if you get a negative number, especially on a square root, you can have it under a cubed root. A cubed root's okay, but a square root's not, so it shouldn't equal a negative out here. And that's kind of, once it equals a negative, I don't even check on the inside. Okay? All right, so what I'm going to do now is I'm going to square both sides to get rid of that, but notice how I'm squaring it. You can't just square the x and square the 1. You have to FOIL it. Okay? So this is where this just got ugly. All right? Okay, so let's FOIL this side right here. So what is x times x? Good. X times 1. And don't I have another one of those in the middle? What's x plus x then? Do I really need to write that middle part down every single time? No, you can do that in your head. I'm okay with that. In fact, you're in Algebra 2, a high level math class, you should be able to do that. Okay? If you need to write it down, though, it's still okay. All right, what's 1 times 1? 1. Now it looks like what we were doing the last couple of weeks with our quadratics. Okay? I'm going to take this 7 and move it to the other side. How do I do that? Good. So what's 2x minus 7x? And then I got to move the 15 by subtracting. What do we end up with? Good. All right. Now what are we going to do? What does it look like we need to do? The magic x. Good. Two numbers that multiply to negative 14 and add to negative 5. So we'd have x minus 7 times x plus 2 equals 0. What property do I need to use? Good. Wow, we really remembered. I think first period just must sleep. All right, what are we going to do with this negative 7? Add it, okay? And put the 2? Subtract it. All right, I need to check these. Okay, and again, I'm not going to write down a ton for my check, but I do need to check them and make sure they work. So what is 7 plus 1? 8. Good, okay. 7 times 7 is? 49 plus 15 is? 64. Square root of 64 is? 8. So is 7 a good answer? Yes. All right, let's put in the 2. What's negative 2 plus 1? 1. Is a radical allowed to equal a negative? No. So is this a good solution? No. That doesn't mean every time we have a negative number, it's not going to work. okay? Because we're going to see one in a few minutes that does work, all right? But this is not a good solution. So now, it's one of the extraneous ones. That doesn't mean erase all your work that has to do with that one, or cross it out so I can't see it. Put a simple X through it. That's your indicator. That one's extraneous. I'm telling Mrs. Ballard that I know that, and I'm going to box my answer that works, okay? Got it? Some extra space for 12, though. You might need extra space for 12, so you could use the space for 10, all right? Okay, example 11, same thing we just did. I need to do what to both sides? Square. So we're going to see another one that's just like this, like what we did, okay? So we end up with 10x plus 9 equals. Over here, does that mean square the x and square the 3? Nope, it means we need to FOIL. Okay? So 10x plus 9 is just going to hang out. What's x times x? X squared, good. X times 3? How many of those do I have? 2. What do we get in the middle? 6x, not 6x squared, 6x. 3 times 3? 9. And you guys, I know we do a lot of, we're adding, we're multiplying, we're going back and forth all within one problem, okay? And sometimes I know you go fast and you answer and you make a mistake, and that's okay, all right? But just make sure you're slowing it down when you're taking the test and you're really writing the right thing and analyzing your work, okay? All right, what do I need to do with that 10 to move it to the other side? Subtract it, what do we get? Good. And what are we going to do with the 9? What's 9 minus 9? Even better, we don't even have to do a magic X. What's the greatest common factor? X. We love this when this happens, because look at how easy this is. Now we get zero product property out, right? So X is equal to 0. We need to check it. We'll do that in a second. What do we need to do? What do we do to move the 4? Add it. So X equals 4. All right, let's check and see if either one of them is extraneous. So I put in a 0. So that would make 10 times 0 is 0. Plus 9 is 9. What's the square root of 9? 3. 0 plus 3 is? 3. So does 0 work? 0 is a good answer. All right, let's try the 4. What is 10 times 4? 40. Plus 9 is? 49. Square root of 49 is? 7. All right, what's 4 plus 3? Did that one work? So it might be that both answers work. Could it be that both answers are extraneous? What would you write down if both answers were extraneous? No solution. No solution's fine. Okay? All right, let's look at 12. 12 got uglier, didn't it? See how it added that extra 1 that's not underneath the radical sign? So you might need the space for 10. Okay? So if you want extra space, write it up on 10. Okay? All right, or write really tiny, because this one gets a little bit longer. Okay? Let me see if I can find my copy of it. There we go. Okay. I'm going to square both sides. So over here, that just means 3 minus x, right? On this side, it means I have to FOIL. I doubt we've ever seen a FOIL with a radical before. Advanced math, right? Okay. It looks way worse than it is, all right? So if you just keep following your good algebra rules that you've known for years, the problem isn't that bad. It's long and tedious, okay? And that happens some nights. That doesn't mean go drop the class, okay? Well, sometimes we have work, a little bit longer work. I'm going to give you double points on the homework tonight, though, okay? Isn't that great? Okay. All right, so I'm going to, we're going to FOIL this. Okay, so let's review really quick. Square root of 2 times square root of 2 is what? 2, right? Radical times itself is the junk underneath. Okay, now listen to this. Square root of x plus 2 times square root of x plus 2 is? There you go, x plus 2, the junk underneath, right? Okay, now we've got to do our outsides, and I am going to write this step down because this is kind of new. So it's 1 x square root of x plus 2, and on the insides, I would have another 1 plus square root of x plus 2. What's 1 times 1? Oh, and all we did there was FOIL. It just happened to be that we had radicals in it. Okay, but we FOILed. That's not new. What's wrong? Cody, you okay?
Yeah, I'm just doing
We all are. Okay, so we have to, this times this, the radical went away, right? Okay, and then I did the outsides together. So that's how I got that. I did the insides together. That's how I got this. And then 1 times 1 is 1. Got it? Okay. And you guys, if you need me to stop, that's okay. If you want me to go back and repeat it, that's okay. My calculus kids, I'll do the whole problem. They go, okay, go back to step 3. I need it to repeat it from there. And that's okay. I don't want you to leave here lost. Okay? It's my goal is to you to be able to do your homework every night without me. Okay? All right. We're combining like terms. 2 plus 1 is what? 3. This acts like a variable for a minute. Okay, so this term here and this term here are like terms. What's 1 squared of x plus 2 plus 1 squared of x plus 2? 2. There's 2 of them, right? 2 squared of x plus 2. Our goal now is to get everything off of that radical. Okay? So I'm going to move the x over to the other side. How do we move that x? Good. So negative x and negative x is what? Good. I got to move this 3 to the other side. How do I do that? 3 minus 3 is 0. So that we have 2 squared of x plus 2 equals negative 2x. All right, now we're multiplying here. So how do I get that 2 to the other side? Divide. Good. So square root of x plus 2 equals, what happens with these 2's? Cancel, so I'm left with negative x. Here's where this gets really fun. Okay. How do we undo that radical? I told you it was longer, right? We're going to square it. So I get x plus 2 here. This, notice the negative's in the parentheses, so that makes the negative go away, right, when we square it. Because a negative times a negative would be positive. Now we're back into quadratic land, right? So I'm going to choose to move everything to the right side so I don't make a lead coefficient that's negative or even has one, okay? So 0 equals x squared. How do we move this x? Subtract it, good. How do we move the 2? Subtract it. All right, how do we solve something like that? Magic x. So 2 numbers that multiply to negative 2 and add to negative 1 are? One of them has to be negative, right? Which one? Negative 2 and 1. So we've got to have 0 equals x plus 1 times x minus 2. What property do we need? Zero product property. And so x equals what? Negative 1 and x equals 2. All right, but I'm not done because could one of them be extraneous? Yeah, I know my for some reason my instructions didn't carry from side to side, but your instructions still say extraneous, so let's check it, okay? Again, I'm not going to write a whole lot down for the check. I'm going to write kind of the answer for each side. So what is negative 1 plus 2? 1. Square root of 1 is? 1 plus 1 is? 2. 3 minus negative 1 is going to be what? 4. Square root of 4 is? So is negative 1 a good answer? Yep, negative 1's a great answer. All right, let's try the 2. Okay. Let's see. 2 plus 2 is what?
4.
Square root of 4? Plus 1 is? 3. 3 minus 1. I'm sorry. 3 minus 2. 1. Square root of 1 is? Did the 2 work? That was extraneous. Okay, so in this case, the negative worked and the positive didn't. That one was ugly. Okay, and let's try it. We have enough time to get it in. Okay? So, plenty of time still. All right? Again, it's better for us to see 2 harder ones in class, right? And not panic when we get them on our homework. Have confidence that we can do them. Okay? All right. This one isn't quite as ugly as the last one was. All right, I got to square both sides. So on this left side, that means I have to write out and FOIL. Okay? So I get x minus 2 on this side. Okay. What I want you to do is I want you to just do the FOIL step. See if you can get the FOIL step done. So FOIL these together right now on your own. I'll give you about 30 seconds to do that. Just FOIL. Don't go any further than FOIL. If you need to look back at the other side, that's okay. All right, we're only going to check the FOIL. So stop doing the problem, okay? We're going to check the FOIL piece. So everybody, what's square root of x plus 6 times square root of x plus 6? Good. All right, and then I've got square root of x plus 6 times negative 2. Good. All right, and we've got another one of those. And some of you, yeah, you're going to be able to do it in your head, and some of us need to write it down. It's okay, either way. Negative 2 times negative 2 is? 4. Okay, now we're combining like terms, so I've got this x. What's 6 plus 4? 10. And then we've got negative 2, and negative 2 is what? Be negative 4 square root of x plus 6. Still equaling x minus 2. All right, we got to move these to the other side. So this is where we should be picking up from here. What do I get? How do I move the x over? Subtract it. So what's x minus x? 0. So the x's go away, right? How do I move the 10? Subtract it. So negative 2 and negative 10 is? Good. So I have negative 4 square root of x plus 6 equals negative 12. What operation do I have here? Multiply. Opposite of multiply is? Divide. So I'm going to divide that negative 4 to both sides. What's negative 12 divided by negative 4? 3. How do we undo the square root? Square both sides. So we end up with 3 squared is what? 9. Let's see. What are we going to do to move the 6? Subtract it. What do we end up with? 3. Okay, but we need to check to see if it's extraneous, right? Notice I only got one answer this time. On the last one I got 2, didn't I? So it was that. See how that problem was harder? Aren't you glad we're not ending with the hard one? Okay. All right, let's check the 3. So what's 3 plus 6? Square root of 9. 3 minus 2. 1. Okay, let's check this side. 3 minus 2. Square root of 1 is? Did it work? So is this answer good? Yep, that's a good answer. Okay? All right, flip to your notebook where you write down your homework. Okay? Let's talk about where this is going. You should be in the week 3 part of stamps, right? So you should be on the right side. I know I haven't stamped last week yet. It's okay. Don't panic. You're still going to get your points. Okay? Sometimes it takes me some time to get it caught back up. Okay? So, this goes in the... So just start it on the top line. Technically, this is the Monday assignment and this is the Tuesday assignment, but what's today? Wednesday. Okay? But I always give you 5 a week, right? So, does that mean don't do only do the first one tonight? No, do both of them. Okay, it's like so I'm basically taking one giant assignment and giving you double credit for it. Right? So you get 100 points for this instead of 50. All right? That only seems fair because it was a harder lesson today, right? Give you more points when it's harder. Tomorrow I'll probably do the same thing. I'll probably take the bigger lesson and I'll split it into 2 and give you 2 homework credits for it. Okay, or I might do it Friday. I don't know where I'm going to catch it back up yet. Okay? All right, that is posted in Haiku. Did you notice that the name of Haiku changed to Power School Learning or something? They got taken over by a company. So it's now Power School Learning. I'll probably still call it Haiku all year long because I'm going to forget the new name. Okay? All right, so you have a few minutes. Okay, you could get onto your Chromebooks and start that assignment. Okay? Is it okay to put these on the same page? Yes, so at the top of your page, when you're labeling your homework, just label it HW number 11 and 12 or 11/12. So that way when I go through and I grade homework, I'm just looking at that top line. Okay? I'm going to come and try to stamp tomorrow. We'll see how long tomorrow's lesson is. Hopefully it's shorter. Okay, and I know I haven't stamped last week's homework. That's okay. Is that your fault that I didn't stamp? No, it's my fault. So I still have to give you the extra credit points. Okay? So don't panic about me not getting it done right that same day, okay, or the day it was supposed to get done.
Do we put it on Mondays and Tuesdays line or Wednesdays line?
Put it on Monday and Tuesday's line, right? So this should go in, so the 5 boxes get filled out every week, right? So this one would be 11, 12, 13, 14, 15. So put this one on the Monday line, right? The 1 to 15, and then put the 17 to 30. Does that make sense? Okay. Hopefully we wrote in pencil so we can fix it. All right. The last day should always end in a multiple of 5, right? Yeah. Okay. All right. So you've got a few minutes.